Hello guys, in this video we're going to review some important concepts from pre-calculus to prepare for the calculus course. Okay, so let's get started. So this preparation for calculus, right? That's the main focus in this video. Now, first of all, let's take a look at the function and its function and the graph, right? Function typically could be written as f of x equal to say given x cubed. This is a typical function, and this is what they call a function notation. F of x is function notation. And the main objectives we are going over first one, using function notation to represent and evaluate the function. Secondly, find the domain range of a function, sketch the graph of the basic functions, and then we also learn how to identify different types of transformation of functions, and then also learn how to classify functions and recognize combination of functions. Let's start with the first one, functions and the function notations. Typical function notation is f of x, right? That's what we use to represent a function. Now the function is one-to-one relationship between the variable x and the variable y. So the variable x is what we call the independent variable. Variable y is a dependent variable. So one x value will produce or yields one and only one y values. For example, let's say we have a function f of x cubed plus 2x, right? This function, anytime you, let's say you generate the x value, and then you plug into the function, you get only one y value, right? So let's say in this case, f of 0 will be 0 cubed plus 2 times 0. So that's 0 plus 0, that's 0. So one x value produces only one y value. Another example could be, let's say x equals to 1, right? You randomly pick x value. Now here f of 1, the y value equal to 1 cubed plus 2 times 1. So it's 1 plus 2. That is 3. Again, one-to-one relationship. One-to-one relationship. Okay. Yeah, so basically function could be specified in different ways, but we just mainly concentrate on functions that are given by equation involving dependent and independent variables. And then the example here, this function or equation is in an implicit form, right? Because we didn't get y by itself yet, but we could do that. Let's say you want to get y by itself, you can take the function, and then you solve for y, right? So it's x squared first. After that, we get 2y equal to minus x squared plus 1. Then we divide 2 across. Okay, so we get cancel the 2, y equal to minus half x squared plus half. And this is what we call the explicit. This is explicit here. Okay. So here the y is by itself, right? So this is implicit form, and this is explicit form. So sometimes you can have to go from the implicit form to explicit form, vice versa, depends on the need. And let's learn how to evaluate the function. And in this example, for the function f defined by f of x equal x squared plus 7, right, we get function here. So we need to evaluate 3 different expressions. A, what is f of 3a? So here then, f of x equal to x squared plus 7, right? Now the x becomes 3a. So going back to the function notation and replace x with 3a. So 3a squared plus 7. So 3 squared 9, a squared plus 7, right? So now this expression is 9a squared plus 7. If you want to get f of b, the second one is Okay, so yeah, let me just quickly erase this. So basically b f over b minus 1. So here replacing x with the b minus 1. So we get b minus 1 squared plus 7. And this is perfect square, so it will be b squared minus 2 times 1 times b, right? Plus 1 squared adding 7. So we get b squared minus 2b plus 1 plus 7. So this is b squared minus 2b adding 8. Okay, that's part B. Part C. So we getting this, we'll call this difference quotients. So we have a f of x here given, and then we need to know what is f of x plus delta x. So in the original notation, we're going to replace x with x plus delta x. So it will be x plus delta x squared plus 7. When we expand it, we're going to get x squared plus 2 times x times delta x plus delta x squared adding 7, right? Now we know f of x plus delta x, and we also know f of x, then we can get a difference quotient. So f of x plus delta x minus f of x over delta x. On the top we get x squared plus 2 times x times delta x plus delta x squared adding 7, and the other one f of x is x squared plus 7 over delta x. Now if we expand it, we're going to cancel a couple terms, right? X squared get cancelled, and then also we cancel the 7 get cancelled, right? Both of them get cancelled. So we get 2x delta x plus delta x squared over delta x. And when we divide into that, we get cancel delta x, 2x delta x over delta x is 2x. Delta x squared over delta x is delta x. And that's how we handle the difference quotients, right? First of all, return the f of x, and then get f of x plus delta x. And this is important operation when we move on to the limit in chapter 2, when we start talking about the limit in chapter 2. And also we're going to take a look at the domain range of the typical function. Okay. Domain all possible x values. Range all possible y values. Okay. Yeah, so domain is a set of all possible x values, range are all possible y values. And let's take a look at this particular function here, g of x equal to 1 over x squared minus 4. So this is what we call a rational function. So the domain is all real numbers except whatever number that gives us 0 in the denominator, right? So we set denominator equal to 0, x squared minus 4 equals 0, and solve for x. So the domain will be all real numbers except those two numbers. Okay, so adding 4 here, we get x squared equal to 4. Now taking square root on both sides of the equation, we put plus minus on the right hand side, so that x equal to plus minus 2. So that means domain all real numbers except plus minus 2. So if you want to form a number line and then try to visualize this, we can do that. You draw the number line, right? And this is from negative infinity to infinity. And then negative 2 is here, 2 is here. So basically we put an open circle there because we're not including those. So that's why we put an open circle here. So that actually split the entire domain into 3 different intervals. Interval number 1, interval number 2, interval number 3. So using the sign notation will be negative infinity to negative 2 union negative 2 to 2 and union 2 to infinity, right? That will be the domain using the sign notation, interval notation, right? It's called interval notation. Okay. Yeah, so and let's take a look at this one. So the domain of this radical function f of x equal to square root of x minus 1. Here domain must be x minus 1 must be greater or equal to 0. So you add 1 from both sides of the equation. Inequality, we get x greater or equal to 1. Then using the interval notation, greater or equal to 1 will be from 1, including 1. We're using the square bracket, meaning including the 1 to infinity. Okay. And then the range, if you look at the graph, we sketch the graph, range is all possible y values. So starting from 0 all the way to infinity, right? So the range will be from 0 to infinity, including 0, right? So we get put square bracket here to infinity. The domain is this, range is this. Also, we can verify from the graph. You see, when you sketch the graph, domain are all possible x values, starting from the 1 all the way to infinity, including the 1 because the solid point here. The range starts with the 0 all the way to infinity, including 0. Right? So that's a range. And then let's look at the tangent function, the domain and range of the tangent function, right? F of x equal tangent x. So in this case, domain are all real numbers except all this, right? This what we call the vertical asymptotes, and this is represented by this one is minus pi over 2, and this is pi over 2, 3 pi over 2, and 5 pi over 2. So that means it will be, if you want to write this in the proper form, that would be pi over 2 plus n pi, right? N here is integer. So the domain is all real numbers except this. Right? All this minus pi over 2, pi over 2, 3 pi over 2, 5 pi over 2. And then the range are all real numbers, right? From infinity to infinity, because it goes up and down forever. So range is from infinity to infinity. Domain will be all real numbers except pi over 2 plus n pi. And here, this one, going from this base, you add pi, right? And going from this to that, you add 2 pi. Going from this to that, you add 3 pi. That's why you add an n pi, right? So it's pi over 2 plus n pi. N is integer. Yes. Pi 2, yeah, 2 pi. Yeah. Okay. So the function from x to y is 1 to 1 if each y value in the range corresponds with exactly one x value in the domain. Okay. Again, it's capable of saying this is one-to-one relationship. So let's take a look at the graph of the function. Okay, so start with the xy coordinates, right? Because for all these functions, in order to graph it, we need some points, and points consist of coordinates, xy coordinates. So the x coordinates is the direct distance from the y-axis, right? So let's say direct distance. This is the direct distance. That's x value, right? And then that would be this. And then the y value will be the direct distance from the x-axis. Could be this. And this is the y value. F of x is the same thing as y. And so each point will be represented as x comma y. Y is the same thing as f of x using the function notation. And graphically speaking, we're using this called vertical line test to determine the function, right?